Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. Okay, so let me check my voice first. Okay, so I'm Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So today we will continue pair of straight lines, and before we begin, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and if you are preparing for IIT-JEE, then you can have two types of subscriptions on Academy. One is Plus subscription and other is Iconic subscription. So in Plus subscription, you get access to daily live classes of all the educators who are teaching on an Academy Plus, and you can watch, you can follow educators of your choice. It's uh, and all live tests and quizzes will also be accessible to you, and you can see the schedule of all the upcoming lectures of the educators. It is well structured, all the courses are well structured, and you can join some ongoing course or you can join some fresh course also. Every week a lot of courses, new courses start, so you can start with a new course also. So this is what, hello, good afternoon, Jia. So this is unlimited access you are getting when you have Plus subscription, and Plus subscriptions price list is this. You can subscribe for 1 month, 3, 6, 12 and 24 months. And left hand side you can see the price, and right hand side after 10% discount. So you can get 10% instant discount you can use this code JEET1. So using referral code you'll get 10% discount, and this is my referral code which you can use, JEET1. Okay. Now this is Iconic subscription, in which you get all the benefits of Plus, which I was just telling you. And apart from that, you get a personal coach who will guide you throughout your preparation for all top exams. All right. Your test analysis will be done in a personalized manner. Your study planner will be customized. Bi-weekly reviews will be given. Okay. So you'll get all these benefits when you have Iconic subscription. And these are the subscription charges. You can subscribe for 6 months, 12 months, and 24 months. 6 month subscription charges are 38,000. 12 months 65,000, 24 months 1 lakh. And again you'll get 10% discount in all these subscriptions using the same code JEET1. Now this is an Academy's learning app which you can download from Play Store. And also let me tell you about the Unacademy's next combat, which is on 20th of December. So next Unacademy's combat for IIT-JEE, which is gamified version of the test. And after the test you'll get video solutions of all the questions immediately after that by top educators. All right, it is on 20th of December. Now we are doing a straight pair of straight lines, so let's continue that. Okay, Jia, I'm asking you one question. Okay, before that, let me tell you the combined equation of angle bisectors. Combined equation of angle bisectors of lines given by ax square plus 2h xy plus by square is equal to 0, right? So as we find the bisectors of two given lines, Alright, so these two lines are represented by our combined equation and we need the angle bisectors of these two lines. Combined equation of angle bisectors, and we know that angle bisectors, if angle bisectors are always mutually perpendicular, so whatever equations we are getting, combined equation, and that, do you know if lines are mutually perpendicular, then what was the condition? What was the condition here? If lines are mutually perpendicular, represented by this equation, what was the condition on A, H and B? Do you remember? Are you there? A plus B is equal to 0. Yes, very good. So A plus B is equal to 0 was the condition, and also relation between the slopes of lines represented by this was the quadratic. Slopes of lines represented by this uh, slopes of lines represented by the equation number 1, okay, given by this quadratic bm square plus 2hm plus a is equal to 0. All right, so slopes में जो relations हैं, the relations are m1 plus m2, sum of the roots minus 2h upon b, and product of the roots m1 m2 is equal to a upon b. We are going to use these relations, okay, relation number 2 and relation number 3. Now let's assume the equation of bisectors. So I'm just telling you I'm just writing a few steps for proofs, and then you can finish it. So steps to combine equation of bisectors. So to find the combined equation, first we need to find the bisectors. So this line is y is equal to m1x, or y minus m1x is equal to 0. And this another line is y is equal to m2x is equal to 0. Y minus m2x is equal to 0. So if I write the equation of bisectors is going to be y minus m1x divided by under root of 1 plus m1 square is equal to plus minus of y minus m2x upon under root of 1 plus m2 square. All right, so if you take plus sign, you'll get one of the bisector. If you take minus sign, you'll get another bisector. So if you multiply these two, you'll get equation like this: y minus m1x divided by under root of 1 plus m1 square plus y minus m2x upon under root of 1 plus m2 square. All right, this is one of the bisector, and the other bisector is y minus m1x upon under root of 1 plus m1 square minus y minus m2x upon under root of 1 plus m2 square, right, is equal to 0. This is the combined equation. Now what is going to happen when you expand it, a minus b, a plus b, so you can write a square minus b square. So I'm writing a few more steps. So y minus m1x the whole square upon 1 plus m1 square and minus y minus m2 square, y minus m2x whole square okay, so we got this actually, y minus m1x, I'm writing it here now, upon under root of 1 plus m1 square minus y minus m2x upon under root of 1 plus m2 square whole square, right, is equal to 0. If you simplify it, then you need to make these relations. You need to eliminate basically m1 m2. Okay, so m1 plus m2 was minus 2h upon b, and m1 m2 is equal to a upon b. Okay, so using these two relations, we need to eliminate m1 m2 from this equation. It is slightly lengthier process, so I'm directly coming to the result. So combined equation, this is the combined equation, okay, but we need to eliminate m1 and m2. After eliminating m1 and m2 using these two relations, we will get this equation, which you need to remember. So directly remember this: x square minus y square divided by a minus b is equal to xy upon h. This is the combined equation of angle bisectors. Combined equation of angle bisectors of the lines given by ax square plus 2hxy plus b y square is equal to 0. All right. Got it? Got it, Gio? Okay, so we are going to use this directly. Like, for example, find the combined equation of angle bisectors of lines given by 2x square plus 4xy plus y square is equal to 0. All right. So the combined equation is going to be, in this case, what is this? X square minus y square upon 2 minus 1 is equal to xy upon कितना आएगा? How much is this? Xy upon, see this, compare. Xy upon 2, yes, xy upon 2, okay. And then you can write this equation: 2x square minus xy minus 2y square is equal to 0. And clearly you can see this pair represents two perpendicular lines, and yes, it should represent, because bisectors are mutually perpendicular. Okay, so this is the combined equation of angle bisector. So directly you can apply this formula and find. No need to separate the lines, no need to find the bisector separately, and then again multiply it. Okay, so we are not doing that process. We are going to apply this formula directly. I hope it is clear. All right. Okay. Now the question is, find the condition if coordinate axis. This is a good question. Actually, you need to remember this result. So you can say this is a result. Find the condition if coordinate axis bisects the angle represented by ax square plus 2hxy plus by square is equal to 0. All right. Find the condition. And later we'll remember this result. Actually, I'll explain it. First, you find the condition. After explaining, you'll get it. Coordinate axes are given the angle bisectors of the line represented by this. Then what is the relation? What is the condition? Condition, of course, on A, B, and H. Yes, good. You're getting the right result. H is equal to 0. Of course, true. So basically, yes, if you write the bisectors, so given equation of angle bisectors is xy is equal to 0. Combined equation of coordinate axis is xy is equal to 0, right? And using the formula, bisectors of this are given by x square minus y square upon a minus b is equal to xy upon h. So you can write this a minus b into xy minus h times of x square minus y square, because this part is missing, so that means its coefficient must be 0. So this h must be 0. So if I put h is equal to 0, this is xy is equal to 0. Okay, so in this way you can compare any line which is two lines are equally inclined to coordinate axis. We know that their slopes are going to be y. See, if this is x axis, okay, x axis is angle bisector, that means two lines are equally inclined to x axis. If two lines are equally inclined to x axis, then x axis will be the angle bisector. So this lines passing through origin and equally inclined to x axis as well as y axis are of slopes, basically of slopes m and minus m. So one of the line is going to be y is equal to mx, and the other line is going to be y is equal to minus mx. So if you find the combined equation, it is of this type: y minus mx into y plus mx, okay, is equal to 0. So it should be y square minus m square x square is equal to 0. All right. So this xy term of xy should not be there. If term of xy is not there, that means lines are equally inclined to. You can also call these lines equally inclined to coordinate axis. Is that okay? These lines can also be called. In this case, these lines can also be called equally inclined to coordinate axis. Is that okay? So these lines are equally inclined to coordinate axis. This was the result. Wait a minute. I think I said something equally inclined. No. I'm sorry. Not equally inclined. Equally inclined. This, in this case, I just said the opposite of that. Coordinate axes are equally inclined. Coordinate axes are equally inclined to these lines. Coordinate axes are equally inclined. Bisectors are equally inclined with the lines. If these two lines are given and this is the bisector, then bisector is equally inclined to these two lines, right? This is bisector or any line parallel to bisector, right? So I just said the opposite of it. Coordinate axes are equally inclined. Sorry for that. You understood this thing? I did a mistake, okay? Yeah, have you got it? I just said the opposite. Lines are equally inclined to coordinate axis. Lines are not equally inclined. These two angles are not equal. This angle is not equal to this angle, okay? So lines are not equally inclined. axes are equally inclined to. All right. Okay. Coordinate axes are equally inclined. Now my next question is, if lines are equally inclined, then what is the condition? If lines represented by if lines represented by ax square plus 2hxy plus by square is equal to 0 are equally inclined to coordinate axes, then find the condition, then find the conditions. Now try it. Now I'm asking that question, that if lines are equally inclined to coordinate axes, then what will be the relation between A, H and B? Bhargav, Bhavesh, today is not doubt session. Today is basically straight lines practice session for class 11th students. So that will not be of any use for you. It's practice session of straight lines, right? You are getting a plus b plus 2h is equal to 0 and a plus b minus 2h is equal to 0. Oh, I was asking, you left, I think, huh? Bhavesh, you left. I was asking for you, but you left, I think. When I got free from others' doubt, I was asking for you, but you were not there. What is the problem in BPT? You can come tomorrow. Tomorrow we have a doubt class, Bhavesh. I'll tell you tomorrow. So Jia, can you write the conditions? Can you write the conditions in combined form? Yes, you are right that slopes will be okay. See, like this. These are the bisectors basically, right? Not bisectors. Lines are the bisectors. These are the lines. X, y is equal to 0. And its bisectors are now given by our combined equation. These are the lines given by ax square plus by square plus 2hxy. So these are the lines. And yes, we know, of course, we know that slope of these lines are plus minus 1. So this is L1 line and this is L2 line. These are basically bisectors. Let me write bisectors, B1 and B2. These are bisectors and these are lines L1, L2. These bisectors are equally inclined. Yes, so this is 45 degree, right? Then this is also 45 degree. 45, 45, so slope of this is going to be 1, so m is equal to 1, and slope of this is going to be minus 1, so m is equal to minus 1. You can also say that the lines given by our equation are mutually perpendicular. See, when did this happen? Whenever two lines are mutually perpendicular, then their bisectors are always mutually perpendicular, right? Bisectors are always mutually perpendicular. But if two lines are mutually perpendicular, what was I saying? 1 minute. So I was saying that when two lines are mutually perpendicular and B1 and B2 are their bisectors, then L1 and L2 will be bisectors of B1 and B2 also. Basically, this pair of L1 and L2 is bisecting the lines B1 and B2, and B1 and B2 is bisecting the line L1 and L2. When did this happen? This happens when two given lines are mutually perpendicular and we are finding the bisectors of those two lines. Okay, so the bisectors are of course bisecting the lines because we are finding the bisectors, but in this case lines are also bisecting the angles between, so they are mutually bisectors of each other basically. Are you understanding these things here? When two lines are mutually perpendicular, then they bisect the angles of their angle bisectors. This is what I'm saying. Okay, so this is what is happening here. L1 and L2 are bisectors, coordinate axis. In this case, if I call this pair 1, so this is ax square plus 2hxy plus by square is equal to 0. This is pair number 1, and coordinate axis xy is equal to 0. This is pair number 2. All right. So 1. It is given that lines are one lines given by 1 bisect wait 1 minute, let me write it properly. Pair 1 bisects the angle given by okay, wait. Pair 1 represents the combined equation of angle bisector of pair 2, right? Also, pair 2 represents the angle combined equation of angle bisectors of pair 1. And why did this happen? Because pair given by 2 represents mutually perpendicular lines. All right, now you got it, right? So now we know that lines represented by this must be mutually perpendicular. So we know that a plus b must be 0. And because they are also angle bisectors, of lines L1 and L2. These are angle bisectors, and L1 and L2 are also angle bisectors of these lines, so H must be 0. And actually you were also getting this thing. You were getting A plus B plus, what were you getting? A plus B plus 2H is equal to 0. And you are getting A plus B minus 2H is equal to 0. So if you add them, you'll get 2 times of A plus B is equal to 0, right? So you'll get this A plus B is equal to 0. You just needed to separate these two relations. So you get a plus b is equal to 0, and if you put a plus b is equal to 0, so you get h is equal to 0 also, right? I'm just explaining this in a different way. You have got the same result actually. Are you understanding it now, Jia? So whenever two lines are given mutually perpendicular, then their bisectors. Bisectors will of course will be mutually perpendicular, but the given lines will be bisectors of the bisectors of their bisectors. All right, if lines are given mutually perpendicular. All right. So this was the theory of homogeneous equation. Now we are going to generalize the equation. Okay. So do you know shifting? Shifting of origin. Let me tell you shifting. Shifting of origin. See, I'm telling you a shifting in a different way. Suppose these are the lines, and this is a curve. This is a curve. This is a curve which is passing through origin f of x y, and this x-axis and this y-axis. Okay. What I want to do is, I want to translate this curve horizontally by x units and vertically by y units. Okay. So to bring this point is say A. Now this A point will be here, which is now h comma k. So this distance is h and this distance is k. All right. So I've shifted the curve horizontally and vertically without rotating. Curve is not rotated. So if original equation of this curve was f of xy is equal to 0, now what will be the new equation? I'm writing that. Do you know that? What is the new equation? Gia? Do you know the new equation of this curve after translation? Horizontally it has translated by h units and vertically it has translated by k units. Okay. So I am not telling you this shifting of origin. That's slightly opposite of this. Actually, that is opposite of it. I'm telling you the translation of curve, okay, with respect to origin. Translation of curve. That means you are shifting the curve, not shifting the origin. You are shifting the curve. All right. Because in 99% cases, you shift the curve. And shifting of origin is just opposite to that. That means you're keeping your curve there, but you're shifting the origin. That means this process can be done in two ways. I mean, this is curve number 1 and this is curve number 2. Okay. This process can be done in two ways. One, by shifting the curve, and second, by shifting the origin. See how can we do this by shifting the origin. So this was the curve. If I shift this curve, if I shift the origin, so I shift the origin by h units leftwards and k units downwards. So these are the new axes. Okay, can you see this? With respect to origin, curve has moved right and up. Can you see this? These two cases are representing the same position of this curve. This is the final position, right? And this is the final position. So in the first one, you are shifting the curve by h units towards positive direction of x-axis and k units towards positive direction of y-axis. The same process can be done by keeping the curve at the same position but moving the origin negative direction of h units and negative direction of k units in the negative direction of y. All right, all right. So, okay, I'll tell you again, okay? Taking a different curve. See, these are the axes, okay? These are the coordinate axes. I'm taking two cases, okay? Keep answering just keep answering when I ask you to. So I'm asking this. I want to shift a curve, okay? Suppose this is a circle. Let's take the circle. It will be easy to visualize, okay? This is a circle whose center is at 0, 0, okay? There is a circle whose center is at 0, 0. And it will have some equation. By the way, its equation is x square plus y square is equal to r square, okay? So forget about the equation. Let's take this f of x, y is equal to 0, all right? If I translate this circle h units towards, I'm translating this circle with respect to its center, okay? So center is now shifted. The whole curve will shift, obviously, the whole curve, but you can see it using center because center is at origin, okay? So what this new position of center is going to be h comma k. New position of center is going to be h comma k. That means the whole curve is translated by h units towards positive direction of x axis and k units towards positive direction of y axis. So now new position of circle is going to be here. Okay, are you understanding this new position? How did we get this? Tell me. Because this is required to understand general equation of, yeah. Okay, now see what happens in the equation, what change will happen in the equation of this circle. So now original equation was f of x comma y is equal to 0. Okay, now in place of x in its equation, x will be replaced by x minus h and y will be replaced by y minus k. So that is the new equation. F of x minus h is equal to 0 and f of x minus h comma y minus k is equal to 0. Okay, so you need to replace x by x minus h and y by y minus k if curve is translated horizontally by h units and vertically by k units. Okay, if any curve is translated horizontally by h units, horizontally in positive direction of x axis and vertically by k units, then its equation x will be replaced by x minus h and y will be replaced by y minus k. Remember that. Okay, y minus, okay, I'll tell you that. For that I need to explain you the shifting of origin. I'll tell you that now. First you understand the two processes. This is one process, okay? The second process of doing so is shifting of origin, okay? Then I'll tell you why this minus sign comes. See, the second process is, again, see, this circle is at origin, okay? I need to make this point 0, 0. I need to make this point h, k. So what will I do? I'll shift. This is shifting of, this was shifting of curve. Shifting of curve. Now it is shifting of origin. See this shifting of origin. So I need to take this circle to h, k, but I'm not touching this circle. This circle will remain its position. I'm just moving the coordinate axis, or you can say origin, without rotating. Rotation is not happening here. Although in case of circle, rotation is not going to matter, but for other curves it will matter. Okay, so how would you translate the coordinate axis? Now if I translate the origin toward in the direction of negative x-axis by h units, and in the direction of, or downwards, you can say downwards, leftwards by h units and downwards by k units. Okay, so now this will be the new position. This is h units and this is k units. Okay, so I have moved coordinate axis h units leftwards and k units downwards. So this is the new position. Now this is your new origin. Then what will be the coordinates of original? What will be the coordinates of original origin? The point which was 0, 0 now will become h comma k, right? With respect to this new O dash. With respect to O dash, can you see this O? With respect to O dash, if O dash is 0, 0, then O is h comma k, right? Are you understanding it now? Yes. So can you see this circle number, this circle, C dash and C double dash are basically same now. The equation must be same. They are positioned, identically with respect to origin or with respect to coordinate axis, both the circles, that's C dash and C double dash, right? The equation must be. That means if any curve which is at origin, or if we need to shift the curve, then we can do it by two ways. Either we can shift the curve directly by taking some point with respect to origin to h comma k. Okay, the point with respect to h comma k will with respect to 0 comma 0 will be now at h comma k. Or you can do the same process by shifting the origin in opposite direction, right? Curve will remain same and origin will be shifted in opposite direction. Okay, opposite direction, you're understanding, right? If you need to take your curve rightwards by h units, that means you need to take origin leftwards by h units. If you need to take your curve upwards by k units, that means you need to take origin by origin downwards by k units. So these are the two processes. Now the proof of that formula. How do we change the equation of the curve? Now see, this we can understand using shifting of origin. See, suppose these are the coordinates x comma y, okay, with respect to origin. Now x comma y means distance from this perpendicular distance. This is y basically and this is x, right? This is the meaning of coordinates. If I shift the origin to some point h comma k, okay, if I'm shifting the origin, then what will happen? These are the new coordinate axes. Then what will be the new position? What will be the new coordinates? Okay, these are old coordinates. Okay, old coordinate means with respect to these old axes. Okay, now these are new axes, x dash, y dash. Now what are the new coordinates of this point P? Okay, can you see this? Can you tell me this distance, this one? P, say this is A, okay? And this is O dash. Can you tell me? Can you tell me PA? PA will be the y coordinate. So what is PA? What is PA? Try to figure out PA. Y minus k, very good. So this is going to be y minus k, okay? And similarly, what is O dash A? This one, this distance, because this is going to be x coordinate. Yeah. So if I take new coordinates x dash, y dash, these are new coordinates, okay? So what is this? Okay, similarly x minus h, right? Now you can figure it out. So basically your new coordinates x dash is nothing but old coordinate minus h, and new coordinates y dash is equal to y minus k. Is that okay? So this is how coordinates will change. Okay. Suppose this is a curve. Okay, this is a curve f of x comma y. Obviously with respect to. Okay, say this is a curve whose equation is f of x comma y, okay, is equal to 0, f of x comma y. So whenever you are writing an equation in x and y, that means it is with respect to the original coordinate axis, okay. The new equation the new equation of the same curve in new coordinate axis. Now listen to this carefully, okay? This is the way to change the coordinates, okay? If some coordinates are given and now he's asking the new coordinates, then you can use this formula. You can find x dash y dash. Now suppose some equation is given in the original coordinate system, in the original system. Now he is asking the new equation, because of course equation will change, because position of curve is changing with respect to origin. So what will be the new equation of this curve? So this is the old equation, right? This is the old equation of a curve, okay, with respect to, you can say, xy is f of x comma y is equal to 0. So whenever you're writing the equation in old system, then it will be in x and y. And when you need to write the equation in new system, it should be in x dash y dash. Okay. So that means this x and y should be replaced by x dash and y dash. How would you replace x and y by x dash and y dash? You need to know the relation between x and x dash, y and y dash. So you have this relation here, right? Using this relation, you can replace x and y. So new equation, that means with respect to x dash y dash is basically f of, now f of x can be replaced by, see this, x can be replaced by x dash plus h and y can be replaced by y dash plus k. So this equation is going to be x dash plus h comma y dash plus k is equal to 0. Okay. Now just tell me, have you understood so far everything? Dear? But this was shifting of origin, okay? If I ask you one question, now you answer me, okay? Now you are going to get your answer. If you have understood this thing, just you need to do one more. You need to understand just one more thing, which we have actually done. You just need to relate it. See, tell me, suppose these are the coordinate axes, okay? This is a curve, say, you can take any curve, okay? Circle or anything. The equation of this curve is f of x comma y is equal to 0. Now you have shifted the origin. This is O. Now you have shifted the origin, okay? Now you have shifted the origin at minus h comma minus k. Origin is shifted to minus h comma minus k. Then what will be the equation of this new curve? Tell me. The new equation of curve. Tell me. Write it. F of, in place of x, what will you write? We are shifting origin only, but at minus h minus k now. Origin is shifted at minus h comma minus k. What will be the equation of new curve? Are you not getting it? Use this formula which we have just derived. So that means x should be replaced by, use this formula, na? This new x dash Now in place of h, it should be minus h, because in the proving part you were shifting the origin at h comma k. So you got this answer. The new equation will be x dash plus h, or you can say x plus h. Finally, you can write x dash as x. Okay. And of course, that x will be different from the original x, but you can write your answer in x and y finally, right? So now the new equation is going to be x dash minus h comma y dash minus k. It's simple thing. You're just saying that now your h is minus h and k is minus k. So yes, result will be x dash minus h and y dash minus k, right? Are you getting this point? You have written the same thing. X dash is equal to x plus h. That means x should be written as x dash minus h, because you need to replace this x. You need to replace this x by x dash minus h, and this y will be y dash minus k, right? You need to write new equation in x dash y dash. Got it now? So this is where you are getting minus h and minus k. Now why? Because if you shift the curve, now relate it. If you shift the curve, suppose this was the situation. I'm telling you the situation. This case is equivalent to this one. Now suppose this is origin, okay? And this point is h comma k. And this is the curve. This is the curve. Okay. I'm not shifting origin. I'm shifting the origin. I am translating the curve by h units towards positive direction, h units in positive direction, and k units in negative direction. So this curve will be now here. This will be the new position of curve. Are you getting this? Can you see this one and this one? Okay, if I call this curve number 1 and this curve number 2. Can you see curve number 1 and curve number 2 are exactly the same with respect to origin? They are looking exactly identical. Are you getting this point? Actually, I explained this thing to you earlier also. Translating the curve in positive direction of x-axis by h units and positive direction of y-axis by k units is equivalent to shifting the origin in opposite direction. So shifting the origin at minus h comma minus k is same as shifting the curve at h comma k with respect to origin. So that's why you are getting this equation, right? So in this case, if original equation of the curve was f of x comma y is equal to 0, then its new equation is going to be f of x minus h. Again, of course, x dash minus h you can write. So this is x dash minus h. Later we'll write it x minus h, and y dash minus k. This is the new equation. So when you shift the curve by h units and k units towards positive x and positive y, the new equation becomes x. In new equation, x is replaced by x minus h and y is replaced by y minus k. So I have tried to relate everything, shifting of origin and shifting of curve. They are just opposite to each other, okay? So whenever he says that he's shifting the origin by 1 unit, okay, let's do one case. Have you got it now? Let's apply it, okay? Shall I move to the next slide? Any doubts? All right. See, equation of a curve is x square plus y square is equal to 1. Actually, it's a circle with the center at 0, 0. Find its new equation if first origin is shifted to 1, 2, curve is shifted to 1, 2 with respect to origin. With respect to origin means the point which is at origin will be now at 1, k. That means it is translated 1 unit towards positive direction of x-axis and 2 units towards positive direction of y-axis. Okay. Third, origin is shifted to 1 comma 2, and this point is 1 comma 2, and origin is shifted to -1 comma -2. Now you need to answer these questions. It's a bit confusing, but you should try to understand it. Yeah, for the first time it might be confusing because we use shifting of curve, not shifting of origin. Mostly we use shifting of curve. So I'll tell you in the end, I'll summarize it. See, like the first case, if you're shifting, if you're shifting the origin, then x will be replaced by, if you're shifting the origin, okay, now listen to this. If you're shifting the origin, then x will be replaced by x plus h and y will be replaced by y plus k, okay? That is the rule. If you're shifting the origin, this is your h comma k. So the new equation is x plus 1 the whole square plus y plus 2 the whole square is equal to 0, okay? If you're shifting the curve, then x will be replaced by x minus h and y will be replaced by y minus k to get the new equation, okay? So new equation is going to be x minus 1 the whole square plus y minus 2 the whole square in this case, okay? The third one, it is again same, x is replaced by x plus h and y is replaced by y plus k, although h and k are negative. So you'll get x minus 1 the whole square plus y minus 2 the whole square, because h and k are negative, is equal to 1, I'm sorry, 1, 1 and 1. Have you understood? So when you are shifting the origin, then x will be replaced by x plus h and y will be replaced by y plus k to get the new equation. But when curve is shifted, origin is keeping the origin same, curve is shifted without rotating, okay? Shifted, translated, without rotation. Then its new equation will be, we'll get the new equation by replacing x by x minus h and y by y minus k. All right, so this is what we are going to use. So in my next class, I'll tell you, you try to digest this thing. Okay, try to imagine this translation, do by your own. Then I'll repeat the theory in next class. Not this theory, I'll tell you the theory of this general equation, because that is nothing but the shifting of the general equation means pair of straight lines. So original pair of straight lines, why are we doing this thing? Because now you know the original pair of lines are basically passing through origin, right? Like this. They are passing through origin, and now because we are going to generalize it, so now they will pass through some other point h comma k. So we need to shift this curve to h comma k with respect to origin. This point will be here now. So directly we can use this relation, shifting of curve, to get the new equation, and then we'll get the generalized equation, and we can relate all the formulae of the homogeneous curve with this non-homogeneous curve, like angle between the lines, because angle is not going to change, right? You can see this angle is not going to change. So first we'll have to understand the equation, the relation between original equation and the translated equation. Then we'll try to form all the formulae. So this is what we are going to do in next class. All right. Understood, Jia? Okay, so I am ending the session here today. We'll continue tomorrow. Today we have a practice session of a straight line, 9 o'clock, 9 p.m. Okay. Chalo, see you there. All right. Okay. Thank you, everyone.